Watch, learn, and we'll be a star freelancer. 24-hour live stream. Save time and money. 100+ free videos and free books with source code, materials, and resources. starfreelancer.eu.
Welcome back. In this lecture, we are going to do the Kubernetes services demo. So let's see what we are going to implement as part of that. So in a Kubernetes cluster, we are going to do a backend deployment. So we have a simple Spring Boot REST services hello world service. So we are going to deploy it. As soon as we create the deployment, automatically its SQL and replica set and then pod gets created. So once that is done, we are going to create the backend app related cluster IP services using kubectl expose. So once we do that, so we will go ahead and then create the front end deployment. So in front end, we are going to create a Nginx pod, and in that Nginx pod, we'll have a proxy to this respective cluster IP service of backend, which is nothing but my backend service. Now, for the users to access our application, we'll also deploy the front end app node port service so that users will be able to access it. So let's go to our GitHub repo and we'll go to our 05 services with kubectl, right? So introductory section we already discussed in our previous lecture. So let's go on to our step 2, which is cluster IP service backend application setup. So let's deploy a simple backend application and then front it with a cluster IP. So the application we are going to use is a simple Spring Boot REST application, just a hello world REST application. So what we need to do if we want to deploy a application, we just need to create a deployment and then front it with a service. So kubectl create deployment, my backend REST app, and the image of that, right? So let me copy this, go to my terminal and then paste it. So it should create our respective application, right? So we can say pods to see our pod is running. Yes. And if you want, you can even say logs-f. Okay, kubectl logs-f and then check the logs of our Spring Boot application. It should be up and running now. Started your hello world application in 3 seconds on port 8080. Okay. So if you see here also, we have exposed, means like we are going to expose as a service with the port 8080, right? And the target port is also 8080. So we really don't need to mention target port 8080, but for our convenience, means like following a standard, so I just put it. In addition to that, you really don't need to provide when you are creating a service using kubectl imperative command expose, right? So you really don't need to provide type is equal to cluster IP here. Reason is cluster IP service is by default created by, means like it's a default service. Okay, so we really don't need to specify that. If it is a type is equal to node port, yes, we need to specify, but for cluster IP we really don't need to specify it. So kubectl expose deployment my backend REST app port, target port, and my service name, my backend service. The service name is my backend service. Okay, so now everything is created. Kubectl get svc. So my backend stuff is completed now. So now I need to create a front end Nginx reverse proxy, and then that Nginx reverse proxy should proxy to this my backend service. So for that purpose, I pre-built the container and then put it here. So if you go to our node port service, so in my Nginx conf, I have put in the proxy pass my backend service : 8080 as the port, whatever we are seeing, right? My backend service, and then port is 8080, right? So if it is not in default namespace and then some other namespaces or something, again we need to give the full cluster DNS name, which is svc.default.svc.local, all those stuff we need to give, but as we are running in the default namespace only, okay, kubectl get ns, right? We'll list the namespaces. This is a different concept which we'll look into it later, but currently we are in the default namespace. We really don't need to provide any full cluster DNS host name here. So that's the reason, to make it very simple for you and not to confuse too much. So I just gave whatever is my cluster IP service name here. the same thing I have provided, right? And then I have pre-built the image and then put it ready. So in our Docker Hub, so we can directly use it and then run these commands and then everything should work for you. Okay. So, and no, I want to create my own reverse proxy related Docker image. Okay. Yes, you can do it. So I have provided the steps and the source here, Kube frontend Nginx. If you click on that, so it will take you to 00 Docker images, 03 Kube frontend Nginx. Okay. So prerequisite is you should have your Docker account, and then you can create your Docker file like this. Everything is present in this v1 release, the Docker file, and which is nothing but from Nginx. You are taking your source image as Nginx, and you are copying the default.conf whatever is there in the current directory to etc nginx conf.d, right? So if you see in v1 release, you will see the default.conf also here. Inside that, you can see proxy pass, backend cluster IP service name, and then port. That's what you have put it here. Okay. So the same thing, and you can go here and then review these things, and then after that you can go into this v1 release folder, right? cd to v1 release, and from there you can build it, docker build -t and your docker hub id and the kube frontend nginx :1.0.0, and take the files from the current directory dot. Okay, and then push that to your docker hub id, and then you can start using it if you want to. Okay, so but for me, like, you can leverage this current whatever the Docker image, and then you can continue, but it's up to you. Just I have given why, because it is Nginx, right? So I didn't give any steps for related to Spring Boot related application. Why? Because again it might confuse you and then create complex stuff, but here for Nginx it's a simple thing, right? So you can try out your Docker skills there with those steps, and then come back and then leverage that here so that you will be more confident. So for that purpose I gave the detailed steps for kube frontend Nginx building. Okay, so now a lot of things we discussed it. So let's go ahead and then create the frontend deployment, and then create the frontend, expose that as a service. Okay, kubectl create deployment, my frontend Nginx app is my deployment name, and the image is kube-frontend Nginx. Okay, so let's take this, and we are here. Okay, created, right? And now let's go ahead and then expose it, right? So clear kubectl get pods, both pods should be running now, and get s3c, we should have two services related to backend service, and then front-end service node port, and then node port id. So if you want to access your application, so you can say get nodes and -o wide, right? And take the public IP here, and 32209 is our port. So let's go to the browser and say okay, and /hello, right? Sorry, so the IP :32209 is my port, and then /hello is the context, right? So we got the response. So let me make it bigger, and if you see it here, 32209 is our node port, and then /hello. So that is the thing. So the same thing we have done it, 32209, and the context is /hello. Good. So now what we are going to do is, so we are going to scale our backend application so that how the load balancing happens, and then you can even see different values here. Where is this? Here, right? So this container ID, right? So this is going to change continuously. So whenever you refresh the browser. So let's test that for our convenience. Okay. So kubectl scale -- replicas is equal to 10, and my backend application. Okay. So I'm scaling my backend application. So let's go here and then scale it. So now kubectl get pods, my backend should be 10 backends I should have, right? So it's coming up. So let's, okay, so all are up and running. So now let's go ahead and then test that now. Okay, so where is this? Here, right? So I'll keep saying refresh, right? Okay, so we can refresh it. something. Okay, see, you can see this is changing continuously. H60 MB now. So it's load balancing across all the backends, right? 9G VFM WNZZ. So like this you are seeing all the containers are up now and then healthy. We are not even seeing that error. Okay, so VFM WG. Okay, so you can see how it is going on. So that's about it. So we have completed our services demo successfully. And one thing here is we really didn't look into load balancer and then external concepts here. So these things we will look into as part of our series of courses, whatever we are doing for AWS, Azure, and then Google Cloud. So in those things, we will extensively look into this stuff. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. So far we have completed from Kubernetes fundamentals perspective. Using imperative way, we have created a pod, and for replica set we really don't have a imperative command using kubectl. So we used the YAML format to create it, and deployment and service also using imperative way we have created it. So now using YAML and then kubectl, we are going to create pods, replica sets, deployments, and then services in a declarative manner using YAML. So let's go ahead and then do that now. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to understand about YAML basics. To write Kubernetes declarative manifest, we definitely need a little bit of knowledge on YAML. So we are going to look into a few YAML basics which are required for our Kubernetes manifest. So let's go ahead and then understand what is YAML on a high level, and then move on and then implement few sample things required to understand better about YAML. So YAML is not a markup language. So YAML is used to store information about different things. So we can use YAML to define key value pairs like variables, lists, and then objects. So YAML is very similar to JSON, which is nothing but JavaScript object notation. YAML is primarily focuses on readability and then user friendliness. So YAML is designed to be clean and easy to read. So we can define YAML files with two different extensions, .yml or .yaml. Anything would work for us. Okay. So the next thing is, what are the core topics we are going to cover here? Okay. So YAML comments, and then key value pairs, dictionary or map, arrays or lists, spaces, and then document separator. So let's go ahead and then implement them now. So we'll go back to our GitHub repo, and we are in Kubernetes fundamentals GitHub repo, and we are going inside 06 YAML basics. So we are going to start with comments and then key value pairs. So in YAML, so to define comments, you are going to provide it with hash, and key value pairs you can see name colon space and then value. So key colon space and then value. Space after colon is mandatory to differentiate key and then value. So let's go ahead and then define this on YAML now, right? So here in our YAML basics, we'll simply say sample file.yml. So I try to use YML instead of YAML in all our notifications, so both are same. So we are going to define a simple key value pairs. Okay, so now we are going to say name is equal to Kalyan and age is equal to 23 and city is equal to Hyderabad. Okay, so everywhere if you see here space, so this space is mandatory for any of these things. Okay, so to differentiate key and then value, so we need to have this space. So if you remove the space, you can see that the notation looks different, right? So have the space and it looks as a key value pair. And now we are going to use Visual Studio Code for that, and whatever you want, you can just go here and then say VS Code download, and then you will be able to download the Microsoft Visual Studio Code. And next is dictionary or map. So what is a dictionary or a map? So set of properties grouped together after an item is called dictionary or map. Okay, so now if you see here, this name, age, and then city are grouped under a property or an item named person. So now person item has these properties. So now this person is a dictionary object. Okay, so now let's define that now. So we are going to say person and like this. So if you define like this, so these are not grouped under person. If you see this one, so this is one more key value pair like it looks, so it is wrong. So now we need to select all these things and then say tab. So we need to have equal amount of spaces here, and now if you see, this is the parent and these look as child. And now under person we have these properties, name, age, and then city. So now this is dictionary. Okay, so now the next thing here is equal amount of blank spaces required for all the items under a dictionary. So we have equal amount of spaces. So one tip here is whatever you select here. Okay, so if you say enter, directly it will come here in Visual Studio Code, and then if you want to write something else, you can write school. Okay, ABC school, something if you want to write, you can write. So directly it will come under the same indentation level in VS Code. Okay, and another important thing here is whenever you are writing YAML in VS Code, so if you want to give these indentations, you can say tab, and then it gives us 2 spaces for us. So instead of typing 2 times space, so you can even say tab, tab, tab wherever you want to write. So that is one way of doing it. So now we completed the dictionary and then map. So let's understand about arrays or lists. Okay, so dash indicates an element of an array. So I have something called, for this person he has some hobbies, and list those hobbies. Okay, so listing means those are lists, right? So now we'll go here and immediately under hobbies, right? So I'm going to say tab, and I'm going to say cooking and cycling. So like this. Okay, so like this you can write those things. Now one more means like list you can define this way, or you can define the list in the other way, which is hobbies and then square brackets, and you can say cooking comma cycling. So in any way you can write the list. So this one we are not going to use. In entire Kubernetes manifest we are going to use lists this way. So now the next thing is multiple lists. So how you are going to define multiple lists, right? So let's example, you have friends, okay, and you want to define your list of friends. Okay, so I can say name of my friend is friend 1 and his age is 23, and I have one more friend, okay, so whose name is friend 2 and whose age is 22, and I have one more. So you can, like this you can keep writing the lists. Okay, so multiple lists. Okay, multiple lists. So that's about multiple lists, whatever we are going to define. So now you can consider this as one document, this person document as one document. So what next? Okay, so you want to write one more document in the sample file. Okay, so in the sample file YAML, I need to write one more document. I really don't want to create one more file here saying sample 2.yml, and then I really don't want to write it here. I want to write everything in a single file. So for that, what I can do, right? So there will be something called document separator in YAML. So I can say this one, and then now I can write one more file here. Okay, so I can copy my sample pod template and then paste it here. Now if you see, so this is a separate document of YAML, and this is separate document, and then it is separated using document separator, right? YAML document separator. That's the thing. So if you see here, this pod template and all these things, we'll move on with the next steps of live template writing, and there also you will understand in detail. But you can see here, you can define, you can come from top. So API version is a string, and then we have v1 value, and then kind is pod and it's a string, and metadata is a dictionary, and you have name and then labels. Under labels you can define multiple values here. Okay, so tier is equal to front end, etc. So now this is one more dictionary. Okay, and under root element spec you have containers, and on containers you can define multiple things. Okay, so here it is one more time, you can say this as list, and under containers this is one container. If you want to define one more container, so you can say name and container is my app2, and then you can write one more image here, right? So I can say, where is this? So I can even write here image is equal to abc slash something stack simplify slash cube nginx 2.0.0. and if you want to define ports one more time for this respective container, then you can even define those things. Okay, and then you can define container port and all the information you can define. So like this you can keep writing whatever you want in the format it is required in YAML. So the core things involved around the YAML is comments, key value pairs, dictionary or map, array list, spaces, and then document separator. These things will be sufficient for writing our Kubernetes manifest. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to write pods definition using YAML. So we are going to go to 07 pods with YAML. So we are going to do this in 3 steps. One is we are going to understand about the YAML top level definitions, and then we are going to create a simple pod definition using YAML, and then to test whatever the pod we have created, we are also going to create a node port service using YAML. So let's go ahead and then do that now. So if you go inside the Kube manifest, you will have 3 files present here, which is Kube base definition, pod definition, and then pod node port service. So the pod definition and pod node port service are going to be empty. So we are going to write them now. Okay, so let's go to Kube base definition. So I'll take you to my Visual Studio Code, and if we go to the Kube manifest, and inside that you can find Kube base definition.yaml, right? So if you see here in Kubernetes, the 4 top level YAML items are API version, kind, metadata, and then spec. So let's see one after the other. So in Kubernetes, everything is nothing but objects. So the core objects what we are discussing now is pods, replica sets, deployments, services, and many more we can add, right? So if you see, we'll start with the kind. So the kind is nothing but the K8s objects, which is nothing but Kubernetes objects, which is nothing but we can define our pod here or replica set or whatever is the respective object. For that, whatever the YAML definition we are writing, that respective Kubernetes object will be defined here, and its equivalent API version we are going to define here. Example, if it is v1 or whatever it is, right? So how we are going to know what is the API version for this respective Kubernetes version, or maximum it is not going to change for most of the time, but here and there new changes comes into these objects, and then this API version keeps changing, not very regularly, but here and there sometimes. Okay, so for that purpose, always if you want to go and then refer the latest documentation, so we can go here, and if we go here, so you can find here. So this is the pod v1 core for v1.18. What is the definition? So let me open it here, and you can see here pod v1 core. This is the API definition. So you can see the version is v1. So which means we can define our version as v1, and then kind is pod, which is nothing but pod, right? So now if you want an example of the pod, you can even see here, right? So now the most important thing here is whatever we are going to try to do here is we are just going to create a simple pod and then expose it as a service. But what Kubernetes recommends is never ever go and then directly create a pod. So always a pod need to be created using a controller like deployment controller or job controller or stateful set controller. Okay, so this is just for our testing and then understanding about how to create a YAML definition for pod. So we are creating the definition and then we are creating the pod, but it is recommended always to create it using respective controllers. So let's come back here, and so let me remove this whatever we have created here, and now let's copy this, right? So this, we are saying these four are the top level objects. One is API version, kind, metadata, and then spec. So what does metadata mean, right? So you are creating a object of type pod and its name, right? The pod name you can define here. Okay, so it can be my app pod, something like that, right? And you can even define additional labels here. Okay, so label can be app is equal to my app pod, something, whatever you want. Okay, so but the core thing primarily is two things which it will have primarily is name and then labels, and under labels you can again define your key value pairs, whatever you want. Okay, so but name is always required for any of the Kubernetes object whatever we create, right? So in the metadata, the one thing important is name and the other is labels. So later when we are doing the advanced stuff, we will even defining the namespaces and all those things, but core is name and then labels will be always a mandatory thing which we need to fill when we are defining it. Okay, so in such a way that which will be useful for us in the long term, or we can make it as a best practice to ensure that in metadata, name and then labels we are going to definitely use it. And finally specification or spec. So spec is nothing but our respective Kubernetes objects specification, whatever we are going to define. So the core content what we are going to define. So let's go and then remove this and then take this and then go to our pod definition here, right? And copy in the pod definition. Okay, so now we have seen that for our pod the version is v1, so API version colon space v1, and the kind is going to be pod, and the metadata, under metadata we already know that name we are going to define, and we are going to say my app pod is my pod name. And labels, right? So when we have multiple number of pods and then multiple objects in Kubernetes, if we want to filter about for this respective application what is my set of pods or set of services, all those things, labels will be very helpful in the long term. So always it is good to define at least one label for our application, right? So again labels is going to be a dictionary object. So if you see here metadata is a dictionary object, and if you see here on that we have defined name and then labels, and under labels again we can define multiple key value pairs. Example, app is equal to my app, and I can say tier is equal to front end. So like this, how many labels you want, whatever you feel like in future you can use it for filtering or whatever the basis, so you can keep defining those things. But for now I will leave it as very simple. Name is equal to my app pod and labels is equal to app colon my app. Okay, so now the specification of our core pod, right? So every pod what it does, okay, it usually runs a container. So if it need to run a container, it need the container image information, right? So it will have a object named containers here, item named containers. Okay, and this containers is a list. If you see here, I can say this as a, so I'm just dictionary. Okay, and again this is one more dictionary, right? So in YAML terms I am defining these things. Okay, so if you see this is a string, right? And again this is a string, right? So containers is a list, which means I can define a list of objects here, right? So why? Because in any pod we can run multiple containers. We have already discussed about multipod applications, right? So we can define multiple containers inside a single pod. That's the reason under containers you can define multiple containers. Due to that, you will get this list object as the containers. Okay, so and I'll say my container name as my app, and I will define its image now. Okay, so I can say stack simplify slash 1.0.0. so this is a simple Nginx image I have built and put it in my Docker Hub, so we are going to use it. So and under this respective means like this is a list, and then if you want to define one more container, you can again define with name, right? So my app backend or something, right? And its image you can define here, and if you want you can define its container ports and all those things. So we'll define additionally ports for this container. Okay, and the container port is going to be 80, right? So I'm going to remove the other container. We are just going to do it with simple one container in a pod. So 99% cases we are going to have one-to-one relation with our pods, so that is pod to container. So we'll also follow the same standard here. Okay, so this is my pod definition. So in our next lecture we'll focus on creating the node port service, but for now we'll go ahead and then create this pod and then verify it. Okay, so let's go back to our browser, and now we have created the pod, and then let's go ahead and then create the pod definition in our Kubernetes cluster, right? So we are in the Kubernetes fundamentals folder. So we'll go into 07 pods with YAML, and we'll go inside kube manifest, and then you can find the 02 pod definition whatever we have created. So you can even see what we have created, right? So now we can go ahead and then run it, right? kubectl create -02 pod definition.yaml. Right, it is getting created. Okay, so now my pod got created. So kubectl get pods, and the pod is running, right? So in our next lecture we'll go ahead and then create the node port service, and then we will test it. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. Let's go ahead and then create a node port service to access the pod whatever we have created using YAML definition, right? So let's go to our Visual Studio Code, and this is the 02 pod definition whatever we have created, and let's again take our API version base and then put it in 03 pod node port service. So now let's see what is the kind we are going to create is service and its API version, right? So let's go here and then take the documentation reference. So I can go back and put it in new tab. Okay, so this is the service pod API object reference. Okay, so let it open. So we can see the version we are going to use is v1 and the kind is service. Okay, so I will say v1, and now let's define the metadata. So metadata is going to be the name of my service. So my app pod related node port service we are creating, right? So nothing but we are creating the name of the service here. Okay, so and now if you want we can even define labels for our service if you want to. Okay, so app is equal to my app. So this is optional for services, but if you want to create we can create. Okay, so if you want to filter our services, means like we have created multiple services for a specific set of applications, and then if we want to filter them using the labels all those services, we can still define our labels for our service. Okay, so and now the next thing is spec. In spec for a node port service, the type of the service we are going to do, which is nothing but node port, right? What happened? Yeah. And the next is, so we'll have something called selector, and one more will be there, ports. In service, these are the high level objects: type, selector, and then ports. So the selector is nothing but, so we need to load balance the traffic across pods using these labels and selectors, whatever we have defined here. So if you see here in the 0 to pod definition, our pod label is going to be app:my app, right? So if you define this in this, means like if you go ahead and then define that respective label here, the same label. So what it states means is load balance the traffic coming to the service across pods matching this label selector. So whatever the traffic coming to this service, if we need to route the traffic to that respective pod, this service is going to identify this pod based on this label app:my app. So this is the key value pair. So based on this selector only, it is going to send the traffic. So whatever is defined in the selector, the labels defined in the selector, only to those pods it is going to send the traffic on a very high level. So let's also define the pods. So we have also seen this, the name of the ports we are going to define is HTTP, and this name is optional thing. Okay, if you want you can define, and I'm going to say my service port is going to be 80, and the target port is nothing but my backend application port, which is nothing but my pod respective container port. Okay, and one more thing we can do here is node port. So if you want, means like whenever we have created a node port service using imperative commands, we really don't have an option to define the node port specific port. Okay, but when you come to the YAML definitions, you get that advantage to define it. So let's go ahead and then define that. So I'm going to use the port as 31231. So you can say this as node port, and this as container port, and this as service port. Okay, so like this you can define all the stuff here in your service. So if you see on a very high level in service, the core thing here is this labels is optional. If you want, you can have it or you can remove it. If you are getting confused with selector and then that label, just remove it. Okay, so in metadata, the name is the core thing, and you have defined the name as my app pod node port service. And in spec, three things are important: type, selector, and then ports. And then type is node port you have defined. So if you are using the load balancer service, you are going to say load balancer, right? Or if you are defining the external name service, you are going to say external name. Or if you are going to define the cluster IP service, you can even say cluster IP. But cluster IP is the default service it creates. You really don't need to define the type there. Okay, so that's about the type node port. And selector and then ports. You will also have selector and then ports. Ports we have defined here. Selector is nothing but whatever you define the label inside the selector, right? So if that label matches with the pod's respective label, then the traffic will be sent to those respective pods, or traffic will be distributed to those respective pods whose labels match with the selector value present in a service. So that's about it. So let's go ahead and then create this service now. Okay, so kubectl create -f and 03 pod node port service. kubectl get svc. Our service got created. So let's go ahead and then access this now. So I'll say get nodes -o void. Right, so I can take any of the external IP here. I can go to browser and 31231, right? So welcome to Stack Simplify Kubernetes Fundamentals Demo application V1 we have up and running. So we have successfully created the pod definition and also the node port service using the YAML. So in our next lecture, we'll focus on replica sets. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create the definition, YAML definition for our replica sets. So this is nothing but 08 replica sets. So let's go here, and as a step 1 we are going to create the replica set definition, and then as a step 2 we are going to create replica set and then verify it, and as a step 3 we are going to create the node port service and then access it via browser and then test it, right? So let's go to our Visual Studio Code, and if you see here 01 is the kube base definition, which will have API version, kind, metadata and then spec. So let me copy this, go to our 02 replica set definition, which is empty. I copied these things, and then let's move on to find the API version by referring our documentation here. Okay, so Kubernetes API reference doc for replica set is v1 apps. Okay, so which is nothing but group is apps and then version is v1. So let's make it as apps/v1. Okay, so if it is core, we really don't need to mention it is core. Just if you type v1 it is good, but if it is apps, then we can say apps/v1, and the kind is going to be replica set. We can see it here. So now one important thing here is 90% of the cases or many cases, what we know, always a replica set will get created or triggered by creating a deployment. So which means like 99.99% we try to create a deployment and automatically a replica set gets created. But why we are learning first replica set and then moving to deployment is both are same. It's not a different thing. But if we change this to deployment, the same thing, entire definition, whatever we are going to create now is going to match with the replica set. And in addition to replica set, we can keep adding more and more features under the spec when you add it as a deployment. Okay, but when it is a replica set, it is only a few things you can add here. But let's learn few things now and then extend it to become a deployment in our next lectures. Okay, always a deployment is a superset of the replica set, or you can say that replica set is a small subset of the deployment features. Okay, so now let's go to metadata. In metadata we already know enter and then tab and then name, right? So this is a dictionary, so we are going to say name is going to be whatever we want. Okay, so my app to rs is nothing but replica set. Okay, so and now let's start with the spec in our replica set. Okay, so we'll have three things here to discuss. So one is replicas. Okay, so second is selector, and third is template. Okay, so now replicas are going to be nothing but how many replicas. Again, these are spec is a dictionary object, and then you have three types of properties under it: replicas, selector, and then template. Okay, so let's start with replicas. So we need 3 pods to be created using this replica set. So that type of definition you can provide here for the replicas. And now the selector. Selector will have something called match labels. Okay, so what does this mean is like, what is your pod definition, how I need to identify your pod definition label, and then have the same thing here. Means like whatever we define the label for our pod, the same thing need to be defined here, so that replica set will identify this is my pod definition, and that respective pod definition need to be ensure that it scales accordingly, or it need to be increased or decreased, everything. Means like replica set will identify your respective pod based on the label you have identified in the pod, and then the same label if you mention in the match labels. Okay, so let's not define anything here. Let's move to the template first. Okay, so template is nothing but your entire pod definition copy should be present under the template. So you already know that we have defined a pod definition in our respective pods with YAML. Okay, so let me copy, means like let me open it in a parallel window. So how to open here is like let's catch control and then right click and open to the side. Okay, and let's make this simple. So now you have your pod definition here. So the entire pod definition from metadata. Okay, so kind and API version is not required from here. Okay, so from metadata to end, whatever is there, that is your pod definition, comes under your template section of your replica set. So go to the starting and then paste it. So is it aligned? So now let me close this pod definition. We really don't need, right? We copied it. Okay, so now it doesn't look like aligned. So why? Because it came at the root element, but ideally it should be under template as a child element. Okay, so what I'll say is select, and one tab, it came directly equivalent to template. So I'll again type tab one more time, so that now Under template, metadata is a child element and it has the pod name as my app2 pod. So we are checking for 2, right? So in the labels, I'll say app is equal to my app2. Okay. And spec containers, and then container name my app2 container or whatever you want to put it here. That is fine. Okay. So that's all. Now this is the template section. So now we need to discuss about match labels, means like selector match labels for our replica set. So whatever the label we have present in our pod definition here, right? My pod label, the same thing should be present here. Okay. So I'll paste it here. So if you see now, under match labels, you have my app2, which means like the replica set will identify this as your respective pod. It need to scale up or scale down. Okay, so this pod. Okay, so one more change we will do here is this one. Okay, so earlier for the pods with YAML we have done 1.0.0. so now what we'll do is like we'll use 2.0.0. so now your tag is app2. This will not be in confusion with the existing my app pod, whatever you have created as a single pod. Okay, so you will not have any issues related to that. Okay, so now let's go ahead and then create this pod and then test it. Okay, so now we'll go here and then now we are going to create our pod. Okay, so let's go back here and I should be in the section 08 replica sets with YAML cube manifest. I am inside that. So I'll say kubectl apply -f and 02 replica set definition.yaml. So if any issues, it is going to throw an error for us. It didn't throw any error. So get rs, it looks good. Okay, so let's wait for the response to come back. So all are running, current and ready, everything is ready. kubectl get pods and we should see the pods running. So kubectl describe pod and then my app2 pod. Let's describe it. Okay, and see if it is 2.0.0 image is running here. Okay, so yeah, I downloaded and then using the 2.0.0. So now one thing we can do is, we already know replica set will ensure that always whatever the defined replicas present inside that, it is going to maintain the same number of replicas. So what we are going to do is kubectl get pods and then we are going to delete one pod and then automatically your replica set should recreate that pod. So it's taking time. So now my replica set related pods are running. So I'll say kubectl delete pod and I will delete this respective pod. Okay, and its age now should be not 93 seconds. Okay, so it should be lesser than that once replica set creates it. Let's cross check that now after the deletion is completed. So one more time, kubectl get pods. So I got a timeout error, we can ignore that. So now if you see here, these two pods are with the age of 2 minutes, but whatever we have deleted, it automatically recreated, replica set recreated, and it is 34 seconds. Okay, so in our next lecture, we'll go ahead and then create the node port service for this replica set and ensure that we access it via browser, and then in browser we get the v2 version of our application. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create a node port service for our replica set and then test it. Okay, so let's go back to our Visual Studio Code and go to our cube base definition and then copy it in our replica set node port service. As we know, for our type of service we are going to create is service and its version is v1 and the name of the service is replica set node port service. And for any service, the following three are the high level things, which is nothing but type, selector and ports, right? So now let's start with the type, the node port service we are going to create. So let's mark it as node port and let's complete ports before going to selector. Okay, so now ports, we are going to have a ports now, so which is list of ports. So now it is going to be name is HTTP and my port name. So this is the port name and it is going to be 80 and we are going to define our target port, which is our container port is 80, and node port, which is nothing but on the worker node what port you want to use, you can define it. So I am going to say 31232. For our pod node port service we used 31231. Here we are using 31232. So now the selector, again as usual, go to your replica set definition, and then this is the label you have in your pod template. So let's get that, and then to these pods it need to load balance, right? Your respective service need to load balance or send the traffic to those respective pods. Okay, so then it need to identify the pods based on a selector. Okay, so that is nothing but label selector. So it is going to be my app 2. Okay, so now your node port replica set service is created. So let's go ahead and then create that now. kubectl apply 03, right? And if any error it is going to throw here, any definition error or something. So ideally no error. So get svc, it looks good. So 31 with 31232, our replica set node port service got created. So we can go ahead and then say get nodes -o wide and get the public IP and then access it with 31232. So if you remember here, so we are accessing 31231 with the v1 application with a plain pod, and with the replica set we are going to say 31232. Okay, and we should have a v2 version of application. So with the plain pod we got v1, and then with replica set we got v2. Okay, so this completes the creation of replica set definition using YAML. So in our next lecture we'll focus on deployment. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture we are going to understand about deployments with YAML. So 09 deployments with YAML. So as we discussed earlier, so deployments are nothing but, again deployment is nothing but a superset of replica set. So we have created a replica set in our previous lecture. So we are going to copy all those templates and then change its kind to deployment, and then container image to 3.0.0 for a difference, and then change the node port service to 31233 for accessing it on the browser. Earlier the pod is 31231 and replica set is 31232. You can see it here. Now we'll use 31233 for deployments, and then change all the names to deployment, in the sense like the file names or whatever we see wherever, right? Instead of replica set, change it to deployment, and also change the labels and selectors to my app 3. Okay, and then create the deployment node port service and then list and then test it. So before going there, let's cross check our API reference document, and for deployment also it is app/v1. So just if we change the kind from replica set to deployment, mostly our things should work. Okay, so let's go to our Visual Studio Code, and this is the replica sets with YAML cube manifest folder. So let me copy it and then go to 09 deployments and then paste it, right? And I'll rename the file to deployment here, okay, instead of replica set. Okay, so that we have it as a deployment reference. Okay, and for node port service, whatever we are going to create, also I'm going to change it to deployment. Good. So now our base setup is done. So let's go to 02 deployment definition, and the first thing is API version, it matched with our this one. Okay, so we really don't need to change anything here. Okay, so only thing is kind is going to be deployment, and the name is going to be my app 3 deployment. Okay, so now replicas are good, selector is good, and the app, which is nothing but the selector match labels, we said that we will change from my app 2 to my app 3. So let's change it. Okay, so and the template, my app 3 pod, I can say this one, name of the pod, and the labels I can say my app 3. So the most important thing is this one, the label and the match label, both should match, and the container name I can give it as my app 3. And finally we also said that we will change the image version. Okay, so for our difference to see on our browser, so I'll say 3.0.0. So this completes the deployment spec update. So we really didn't add any new tags or anything. So this is like anywhere replica set is a subset of deployment, right? So all these things should work as is without anything. So for deployments, we can keep adding more and more stuff based on like how the deployment should happen, and then like it should be in a rolling update fashion, or it should be in a recreate fashion. So update strategies with the recreate or rolling updates. So all those superset options you can keep adding to your deployment if you want to. But the base is replica set and then deployment, more or less it is going to be the same way. Okay, so now let's go to node port service, right? So this is good and no changes required inside that. So let's go to node port service, and this is going to be a deployment node port service. Okay, and the selector is going to be my app3, right? And the node port I'm going to change is 31233. Okay, so now we have quickly completed creating the deployment definition and deployment node port service. So let's go ahead and then create them now. Okay, so we'll go to 09 deployments and we'll go to kube manifest, and I'll say kubectl apply -f 02 deployment definition. And if you want to also at the same time create one more, so that is nothing but 03, you can do this way. Okay, so now two files you have provided for kubectl to create. So it created my app3 deployment and then deployment node port service. So I'll say kubectl get deploy, which is the alias, and it's up and running. So I'll say kubectl get pods. So I should have 3 more pods related to my deployment got created. I should have 2 replica sets, right? One for the replica set whatever we created, and one which deployment created. Okay, and I'll also see the SVC. Okay, and it has the 31233, which is deployment node port service. So, and we'll get the nodes -o wide, and we'll get the node IP, and with 31233 we are going to access it in browser. Okay, so next one, http://31233. Okay, and we see the v3 version of application. So with pods, v1 application, it's up and running. With replica sets, v2 application up and running, and with pods we have v3 application. So now we have successfully created the pods with using the deployment, and then we have tested it using node port service. So in our next lecture we'll focus on services, and there, as we already seen node port service effectively, there we'll see cluster IP service, and also we'll create a front end and back end application in services, and then understand it in detail and then test it. So I'll see you in the next lecture. Until then, bye bye. Thank you.